So I'll show you how to create one simple graph using LangGraph. Okay. So our target is see graph is nothing but you have nodes, you have edges and all those things, right? In the same way, in LangGraph we have a start, we have end, in between we have some nodes, and one simple node is the starting node. Starting node will be there, a starting point, and after that one node will be there, and after that it will, based on a condition, it can connect to node 2 or node 3, and after that it's going to end. This is the simple graph that we're going to create. Okay, for this we need this package, nothing but LangGraph, pip install LangGraph. You can use this, or if you are, I'll show you these things. You can already, you can do it in terminal also. For time being, I'm doing this in a Jupyter notebook. Okay, so IPYNB file, or you can simply, you can see this. You can try this. Simply, you have to install the package, pip install LangGraph. That is done, and after that, uh, so we have a state means nothing but memory. So what it has to, we have to define, right? So there is a, in Python there is some package that is not typing. So typing or typing underscore extensions, from that we can use type dict. Type dict means in general you have a dictionary, right? Key value pairs will be there. So this is one of the data types, so you can simply, you can assign that. You can mention like graph state, you can give the values string. So in the same way, you can do multiple things like comma, and after that I can do uh, state underscore where that is equal to. So I can give int. In this way, I can do whatever I want to do. Okay. So, but so that's a nothing. But you just created one class as state, and you given that so it has to be given it as a type dict, and after that you assigned some variable, you created one class variable, and this is nothing but a string. That's what you did there, and after that you have to create nodes, right? So this is what we have to do. So we have to create nodes also. So how we have to create, nothing but it's just a Python functions. The nodes are nothing but just a simple Python functions. You have to assign some state, whatever we created on the top, right? This one. So we have to pass that as a positional argument. And after that, because of this, you can access the graph state. That is nothing but this variable. So that's it, right? So if you pass this, so that you can do some dot method in case if it is a class variable. So you created one object using dot, you can access the class variables. In the same way, you can do this step. See, you can see this, you can check this. So in this way you can extract the graph state. That's the advantage of this. So that's why we have to create our own functions. So because we have to create our nodes, so I need three nodes. I have three nodes, so I have to create three functions. So each function for each node. So first node, after that you have to pass this state, because you have to pass this state, right? Otherwise it can't hold anything. So state has graph state, these things. So what it was doing, what it will return. So let's say whatever, let's say you call this one, so whatever you passed as an argument, that it will get. After that it will return the graph state. Graph state means what? So this one. So I hope you got it right. So it's a dictionary, so you are passing that with a key so that you can get the value associated with that. Same thing, same concept, right? Now you got it. So currently, if it is a node 1, we are printing I am. So node 2, happy. So node 3 means sad. Same thing. You can see this entire thing is same. Print node 1, print node 2, print node 3. Even if you don't, if we remove this, that is also fine. But for our understanding purpose, we are just giving node 1, node 2, node 3, and we are returning in this way. Graph state, it has to return what is the current state value plus associated with this thing. So this is nothing but nodes. We done with the nodes. Like we created the components. Node 1, node 2, node 3 is done. Now we have to connect, right? It is nothing but edge. So that's the one we have to do. So edge is nothing but, it's what it will do, connect the nodes. Normal edges are used to like go from node 1 to node 2, but conditional edges are we are using so that it will decide. Let's say you don't have node 3 here, so directly, so let's say you can ignore this entire thing. So uh, start node 1, node 2, end. So this is one flow. So for that you don't need any conditional edge, you just need an edge. That's it. So now why we are going with conditional b, because based on a condition it will decide which one it has to choose, node 2 or node 3. That's why we are going with the conditional edge. So that's the difference between edge and conditional edge. Okay. So we just declared one function here, decide mood. So based on our mood, I'm deciding like, okay, let's say, mm, I don't have any condition, so you can decide based on randomly. You can go ahead with that, and you can decide either you can do node 2 or node 3. So there is a in typing, of course, same package. There is a literal. What it will do, it will give literal means at the end you have this method. At the end, it has to return node 2 or node 3. Apart from that, it can't return anything. That's the advantage of this literal. So even if I push something, right, it will throw me an error if I call this method means. Okay, so that's the advantage of this literal. So what it was doing, whatever user given, right? So the state, of course, here also we have to pass the state, and same thing. We on the top we created the class, right? That state we have to pass this one. So this one we passing as an argument. This one we have to pass, and after that, that will be stored in this user input, and randomly it will generate some value, right? So if it is less than 0.5, then it will return node 2. If it is greater than 0.5, it, let's say this condition is failed, then it will return node 3. So, so for graph construction, as I displayed on the screen, right? So you need start node and you need end, you need conditional. These things required. So from where you can get from LangGraph itself, you can get LangGraph and start graph. This is one you have to tell, right? So I'm starting a graph so that it will indicate. So then after that, you need start and you need end. By default, these things are available in the LangGraph itself. So you don't need to worry. So you just need to define node 1, node 2, node 3. So this is IPython is just to display the image. We'll showcase that flow. Here we are displaying this, right? So this flow chart. In the same way we display LangGraph. So for that we are using this IPython.display. Okay, that's why we are using this Jupyter notebook. In this way you can get the graph if you execute this. Okay, so first we initiated this state graph where whatever is there, right? So from the line graph that we taken, and after that we are passing the state where we are getting this state. So from the top we already created state, right? So that we have to pass, that one we have to pass in, and after that this is a builder object, and in the builder dot we're adding one node 1. We're naming this is the name we given, right? Node 1, this is node 1. Whatever node 1 is there, that we given there. And in the same way we created three nodes. This is the name and this is the actual function. In that you can see this, you have this node 1, right? This one we are passing there. I hope now you got the clarity why we have to given this. You can change this entire thing, but whatever function you given, right? So this one we have to pass, otherwise it will fail. Okay, let's say uh, in case of node 1. So okay, first I'll execute this, then I'll replace the values, then I'll show you what it's going to happen. So in this way you created three nodes, separate node 1, node 2, node 3. And after that, first from the starting point to node 1, there has to be one connection. You can check this one. So from the start to node 1, there has to be one connection. This one we have to do. How we going to do? So this is the step. So builder dot add edge. So that is a normal edge, right? That's why start and node 1. Next step is so now this connection is done. After that you have to do node 2 or node 3. There is a condition. You can't do normal edge here. You need to do conditional edge. That's why you taken this conditional edge, add conditional edges, and after the node 1, you have to decide which one it has to do, right? So decide mood is there. It's a function, right? It will decide whether it has node 2 or node 3. That's why we're passing this here. So this method anyway returns either node 2 or node 3 value. So that's what we're connecting. And after that, node 2 to end, after that, node 3 to end. So this will automatically, like in the graph itself, you can see node 2 to end, node 3 to end. So this is the flow we created. Like in this way, we constructed the complete graph. and after that we have to do this builder.compile, so that entire thing will be compiled. After that, using this display, we're able to let me run this. See, it got executed and it given this one. So you got to know start node is there. So from the start node, you from the start you have to connect to node one. That is done. Then after that, conditional edge is there. Node one to node three. There is a conditional. That's why we got this kind of dotted lines. If you see this. Then after that, node three to end, node two to end. Next, graph invocation. So we have to check, right? We created the graph. We need to do so we have to invoke and we passing this graph state. Why? This is a state, right? Like meaning we created our class, so there is nothing but state. This is the graph state. We have to pass one string. Okay. You can come here. You can come here. Graph state. Hi, this is Lance. So let's say I'm giving my name. Hi, this is Perumal. Okay. So let me run this. See, you can see this. There is a condition, right? First node one is executed. Node one is nothing but whatever I given, that is a node one. After that, uh, sorry, I am is the whatever this is the data, right? I can show you this. What is the function we decided on node one? State and whatever state you given, after that I am will be added to that. That is a node one. This is the default step. Next condition is there. So it will decide either node one, node two, or node three. Whatever data you have after that, so currently I just given hi, this is Perumal. After that, node one is executed. That's why I am will be added to that string. After that, either this or this will execute based on condition. Condition also randomly, because that's how we created our logic. So sometimes it will be happy, sometimes it will be sad. So that's why when I executed it, when I run this script, hi, this is Perumal. So node one, node three executed. Node three is sad. That's why this is sad. So let's say I again rerun this. Now it was changed to I am happy, because random, right? So sometimes it will do. Now it again gives happy because the value is greater than 0.5. Again it given. Uh, Now we can see node 1 or node 2 are executing. Again it's given. Okay. Now see, it was changed to sad. So that's how it will working. So it's completely working fine. So so you can change this. Now what I will do, instead of this node one, node these things, right? I can change the names. Functions will be same. I'll do node A, node B, node C. Hmm. So I'll do this start to node A and node A and node B, node C. So let's run this. Okay, we got error because somewhere we have to do node 1, node 2, node 3 also. We defined. Okay, okay. This one also we have to change like node B, and after that node C. So either it has to return node B or it has to return node C. Okay. Okay, let's run this thing. Let's see how it goes. We'll see. See, now you can see this node A, node B, node C instead of that entire thing, right? So this is how you can change. This is how we have to do experiments. You have to understand the concept by changing the things. So now it was giving node one, node three because functions are executing. Functions, this function will execute. This is we didn't change. That's why. So let's say if you want to change this, you have to rename this to node A. Then let's say okay, this is a print statement, right? I can do it. Won't be get any issues here. And node B, and after that node C. So yeah, I think uh, I think we're done with this, and in this way you can implement the thing. Hey everyone, this is the second episode of LangGraph tutorial series. In the last video, right? So we covered how to create a simple LangGraph with the nodes, some normal edges, and some conditional edges. So this is the uh, script I think we covered this, and I showed you clearly how to start and how to create the nodes, and after that, what is the normal age and conditional age. So that's it, right? So we covered that. Now our target is we know how to create normal graphs using LangGraph, how to create nodes, how to do the conditional edges and normal edges and all these things. Next, our next topic is like how we can use LLMs in our graphs with the help of like in the LangGraph, how we can access LLMs and basically chat models, and how can we access chat messages, and how we can see like we'll cover tools and how to execute those tools in the tool calls and function calls in the next video. But today I just want to focus majorly on this part, like how can you access chat messages and at the same time chat models. Okay, so our target is, let's say you have a starting point and you have the step one, that is node, and after that in the middle of the process you want to access one of the LLM. How you going to access your LLM? So how you going to access the chat messages? How you get the conclusion? That's the process. This entire thing is known as chain. Chain is nothing but you have nodes, and within the nodes you have some LLM calls and all those things happen, right? This entire sequence is nothing but a chain. Okay. So first we have some dependency. So earlier, like we people are using with OpenAI, and you can go ahead with that. But I know OpenAI is paid one. You have to pay for it, and let's say you don't want to pay anything, you want to learn something, and then in that case you can go ahead with the Google Gemini API. I already created a tutorial like how you can access so free Gemini API, so you don't need to pay anything, so you can just refer this video. You can get the clarity like how can you access Gemini API without paying anything. Okay, so provided you can go through that, you can understand. So first step is to install the dependencies. You need to have this LangChain Google Gemini because we are using Gemini model. That's why. And after that, OpenAI, you don't need to use it. Okay, so if you want to use it, you can keep it. And Google Generative AI, these things are necessary. You can check these versions. In case if you face any compatibility issues, just copy that and paste it to ChatGPT. It will return you what kind of a version you have to use. Just replace it here. That's it. First step is we have to understand what is messages. So in chat models, right, you have to deal with messages. In general, there are two types of messages. One is AI message, another one is human message. AI message is also known as system message, right? So there is a package that is known as LangChain core. Within that, there is a module that is known as messages. You can see this. From that, we can import AI message as well as human message. What it will indicate is here in this step, right? We didn't call any LLM here. It's just an indication, like to tell to the model, like this is AI message, this is human message. Let's say I set some context, right? I created some system configurations or system context. At the time it will be very helpful for me if I use this kind of a metadata, all these things. So what it will indicate, instead of telling the model like, okay, this is a AI message, this is a human message, you have to come up with this. Instead of that, I can simply use this from this LangChain core messages. I can access this methods, so that by default it will indicate like, okay, this is a AI message, this is a human message. I can give name also, like model. Here I given name as model. Let me run this so that we'll get some clarity. Just do shift and enter. Okay, you can see this. First is AI message, and what it was, name is model. You got this. So you said you are researching ocean mammals, and after that message, whatever messages is there, it's nothing but list. Okay, so it's not append. What you appended at the end, in the next element, you are adding human message. It's a sequence, right? A message is there, human message is there, a message is there, human message is there. That sequence is there. So that's why you are maintaining in this way. The name is model, and whatever message you given, you are getting here. Next is name is Lance. It's a human name is Lance, and yes, that's right. Then after that, you have to, then again model was responding, like this is just we setting the context. Here our target is how we can access the messages module from LangChain core, and how we can understand AI message and human message, so that we can feed this thing to the LLM, so that LLM will understand the things in a better way. That's the purpose of this package. This entire package is why we are understanding. So my target is to understand step by step, so that at the end, whenever you creating your own application, at the time you will feel comfortable. Okay, there is a module that is known as available in LangChain core, that is messages, from where I can access AI messages as well as human messages, right? That's my point. I'll show you, I'll change this data so that we'll get more comfortable and more clarity. So then AI message is like, okay, name is model, and after the great, what would you like to learn about? Then Lancy, the person who's saying like, I want to learn about best places to see forecast in the US. Okay, this is the question. Okay, now what I do, I'm using Gemini, right? I'll say Gemini model. Instead of normal model, I'm making lesser. So instead of Lance, I'm using Perumal. Nice, my name. Why I should give someone name, right? So yeah, so I'm using, okay, again I'm using Gemini model here. So Gemini model. Again, my name is Perumal. Um so okay. So first we'll check how the messages will appear, right? So let me uh print one statement like print, okay, so message. What we have to see, we want to see how the message will look like. Messages, it's a list, right? So how it has to look like. And after that, instead of pretty print, I'll just print each line. Okay, forget first, let's check this. So how it's going to see. Control S, and after that shift run. See what it was doing. So it all was appended. First is AI message. So you said whatever you data given, that is coming here. Apart from that, you can see this additional keywords, keyword arguments, response metadata, name, whatever name you given, that is displayed here. This is the advantage of this AI message. Like from the LangChain core messages, apart from whatever you are passing, so you can pass some extra keyword arguments and response metadata. In this way, so you can, it will be very helpful whenever you are sending some kind of a data to the model. It will have some additional context, like you can pass some additional keyword arguments, you can pass some metadata, all these things can be done. That's why we are using this kind of AI message and human message from the LangChain core. Okay, so entire thing will be appended. Okay, now same thing. So now you got the clarity. Whatever you give here, like it will display here. So let's say you're feeding this entire thing to the model. So instead of you know uh, instead of normally giving this, you are giving the things in a better way. So now the model will understand, like you'll pass this kind of a data to the model. So if you pass directly question, or if you pass this particular format, obviously this format will makes the model in a better way, it will give the response in a better way. That's why we are using this LangChain core messages. That's the point. Okay, so that's it. Just to comment it, just on this. So this is what the data is. Next, you ask the, at the end, you human question is, I want to learn about the best place to see overcast in the US. This is the question. Okay. Next, we are using chart models. There are many chart models are available, like OpenAI is there, Gemini is there, Llama, Mistral, all these things are there. But for our, in this entire tutorial, so instead of OpenAI, I'm using this uh, Gemini. So you can, this is the logic. Okay, so you can, from the LangChain Google Gemini, you can use chat Google generative AI. You can configure your API. So instead of giving it like this way, you can set in environment variables, you can do that also. But for time being, I'm just given like this straightforward. This is a explanation, right? In case if you're implementing some production level solution, you don't need to do like this. You have to store this in .env, and after that from the load env, so you can access the credentials. Okay, so so now what we are using is Gemini 2.5 Flash model we are using, and whatever messages is nothing but, here we have the messages, right? We have this entire data. That is what our target, right? We have to call the LLM how it was responding. So we are passing this and we are checking the result. How we are going to get? It's just a normal LLM call, but what we are doing is our what we are trying to do here is we are using AI message and human messages from the LangChain code. We're just checking how well it was giving the things in a better way, right? So now we are passing this entire thing to the model, and Now we're just checking the type. Okay, what its type is. It given LangChain core messages.ai message. Now you understand, right? Like how it was giving the response. Itself you can see we given human response. Next step is AI message, right? That is the advantage of this LangChain core messages. It will clearly tell you what is human message, what is AI message. In that way, we'll understand better. So let's say in coding in complex situations, you will know, okay, this is AI message, this is human message, so that we'll get more clarity. That's why we are using this LangChain core messages. From LangChain core, we're using this messages. Message is nothing but a method which is available in the LangChain. Okay, so LangChain core. Yeah. So now we got to know this. And if you print the result, you got the message. So when it comes to seeing forecast, this is the question you ask, right? As a human, what you ask? You ask human last messages, I want to learn about best place to see forecast in the US. So it given. Okay, so let me run it again. You can see this, it was taking some seconds to give the data to you. See, this is this. Now let me run this. See, if you're looking for the best places to see forecast in the US, the Sam Juan Islands in Washington State are widely considered the top spot. You can see this message format also. It was changed a bit. Why it is the best? It given the reason and everything. It's just normal LLM call, but compared to direct task, right? If you give like this, so it will understand. Okay, this is a message. This is human message in this way, and also you can check the metadata also. For this Gemini, there is no such metadata. Okay, so that's it. So, in this video, we learn how to access these messages, and you can see this uh, metadata. So that means, okay, got it. So let's say instead of this response metadata, there is usage metadata. I think in OpenAI that is the response metadata. If you do this, now you can see this. What is how many input tokens are there? This is how you have to do, right? So this is how you have to know. You get the clarity like what is this ID? This is nothing but a response metadata. If you look at this, yeah, response metadata is nothing and got it. So the usage metadata, you get the number of input tokens you ask, number of output tokens given, total number of tokens, all this information you can get, right? So yeah, so in case you just want the message content only, so what you can do, so simply you can, I think it's result dot content. So let me add one more thing, result dot content. Yeah, that's it, you'll get only message. So, see, this is how you have to do some trial and error so that you can get more clarity. So you have to understand, okay, how you have to print that, how you have to understand it. So this is my point. Okay. So next what I'm trying to do is I'll explain you how to use the tools and what is tools, what is definition and all those things. And we'll practically implement one tool call here, function call here in this LangGraph flow. Okay, so this if I tell all this thing on a single video, it will be overwhelming. So that's why I just want to cover how we can use this LangGraph and sorry LangChain in the LangChain core messages. How we can use AI message and human message, and how can we display the things. How we can pass this entire data to model, and how we can get the response instead of OpenAI. We are trying to going with Google GenAI. That's it. This is what I want to cover here. I hope you will learn something, and we'll see you in the next video. I'll try to cover these tools and hey everyone. So in this video, we'll learn about tool use, like what are tools and how can we implement tools in graphs like lang graphs. So that part we'll try to cover. So first point is like what is tools? See, uh, tools you can think like simple functions only. In Python we have functions, right? Methods. In the same way, tools are nothing but functions. The tool use, or some people will call it as function calling also, tool calling also, all these things are same. They can say as tool calling in some terminologies they mention it as a function calling. Okay, but what is the concept here is, let's say your LLM has to interact with some of the external systems. Consider, let's say you are building one project, you have your internal company based database, right? So uh, that you can't tell LLM like you know go for it and get the data. No, it is not possible. But what you can do is you can create one method and you can give that method schema to model, like okay, see, whenever you can tell the model like whenever there is a requirement like this, you have to call that function. Then what LLM will do is like, okay, it will understand whenever that's what agent means. Like it will understand, let's say this example, consider this example. It's a very simple example. What is 2 times 3? So that means simply you have one tool that is nothing but multiply. Whenever user asks any query, so it can, what this method will do is it will take two parameters and it will return the multiplication of that product of that values. So what we are trying to do here is, with the help of bind tools, so model will tell you like, okay, user asked this query, and it will understand like, okay, this is the query and this is related to the existing tools, and what I have to do is I have to give the parameters like this: a is 2, b is 3. Like let's say user asks this one, so you can't directly apply multiplier it because it requires two parameters. How you know like, okay, the a is 2 and b is 3? You don't know. That's what model will do here. So what it will do, it will understand, okay, user asked me this question, what is 2 times 3? Then, okay, the first parameter is A, second parameter is B. So that is 3 is B, and it will return like, okay, A is 2, B is 3. User is asking to multiply. What is 2 times 3? It will understand, okay, 2 times 3 means multiplication. So we already have one function that is known as multiply. Okay, I have to give this thing to the solution so that you can call this function, then it will return some response that you can give back to model, and it will take the entire thing, it will return it in a better way. So this is the entire flow. So ultimately what I'm trying to explain here is, we can create multiple tools, and LLM role here is like bind tool. Role here is it will tell you which tool it was calling, and which tool it was taking, and which tool it was formatting, like arranging the things, all those things, that will happen with the help of bind tools. Okay, we'll see some examples so that we'll get more clarity. We created one method. We're creating one tool. You can say it's nothing but a multiplication function is our tool. So we have two arguments. One is A, another one is B. And if you pass this, you can return some value. That's production, a product value, A cross B. A multiplication B. So what we are doing, we already created one LLM instance. These things I covered in the previous video. You can check that. We already have this LLM. Okay, so LLM, and after that bind tools. Whatever bind tools is a method, so it is available. And like, let's say we have this LLM, we initiated chat. By default, this has this bind tools method. So you can bind tools, whatever tools you have, you can pass that. Okay, so that LLM will understand, okay, I have tools in my pocket. So whenever user asks any query, I have to check these tools. If this is not happening, then I can go ahead and give some other response. Okay, so now if I pass a query like what is 2 multiplied by 3, then it will understand, okay, the user is trying to do the multiplication and I have to call this tool. Okay, now I have to give the parameters like A is 2 and B is 3, and what tool it has to perform, it has to perform multiply because that is the name we given here, right? Okay, so we can run this also instead of what is 2 multiplied b, I can say, uh simply I can say like, multiplication of um, 9 and 5. Okay, or let's say 2 and 7. 2 and 7. Name is, I'm changing my name to Peruma. Just run this. See, it was run, and you got the arguments, right? So A is 2 and B is uh okay, sorry, have to fix this. Yeah, now you can see A is 2, B is 7, and we have the ID. What we have to do, we have to do the multiply call for from the, you know, or we can try this product of. I didn't clearly tell the model like you have to call this method, right? So, but it by the intent itself, it was I understanding. Okay, I have to do some tool call here based on the user given prompt. You can see this beast is, and it is a tool call, and it's clearly given. So I have to do the, so multiplication, right? So just now I executed. So what it will do, it will do this tool call, and that's how it will understand. Now what we're doing, there is a message states. These things are already available in, um, you know, LangChain itself. So let me rerun this. And after that, we have these reducers also. It will override these things. You don't need to remember too much. And we created one class that is known as messages state. And how we created another previous class. Right? This is a type dict, and we are using annotated. Annotated means, I can show you with one example so that you will get more clarity. Let me open this. This is annotated. What it will do, it will take the first one as a type, data type, and after that you can put some condition also, like this, like this. You can put the score is annotated, and you can give the score value, whatever value you are giving. It has to be the data type in, and it has to be greater than 0. So in this way, or you can give name, and the maximum length is 50. So in that way, you can use this annotated. So in our script, in our code also, what we are doing, we are using annotated. The messages has to be list. The data type has to be list of any message, and after that we have to pass add message. It has to be related to messages. This is what we are trying to create here. Okay. So let me run this again. And after that, this is just for reference. You don't need to worry. And these are the initial messages we are just trying to add here. AI message is hello, how can you assist today? Human is asking one question. I'm looking for information on marine biology. The name is Lance, and after that we are trying to add new message. And we are using this add messages function so that we are just checking whether the one is appended or not. If you run this, these messages will be appended at the end. So now what we are doing is we are creating one graph here. Like earlier in the previous video, how we created that entire flow, right? In the same way, we're trying to create one graph. Here, what we are doing, so we are doing this LLM with tools. This is the one we are trying now. So our entire agenda in this video is, in this episode is, what we are trying to do is we want to um, tell the model like we have these tools with us. Whenever there is a user ask any query which is related to tools, you have to call that tool. That is what we are trying to do. That is what we are learning now, so that in our further sessions we'll understand. If you have thousands of tools, let's say you have 10 tools, you have to tell the model like I have these tools available. You have to, whenever user asks any query, you have to pick the tools. How we can tell these things to the model, how we can implement or integrate these things to the graph, LangGraph. That's what we're trying here. Okay. So we defined one method, tool underscore calling LLM state. What this message stated in the top, we created one class, right? So class message state this one. So this one we're calling. So what it will do, it is nothing but list of messages. And the data type is this. So this is a data type, and generally we're passing this messages. That's a simply you can understand in this way. What we are doing is the same thing. We created type dict, right? There is one dictionary key, and the value is this. So I'm passing LLM with tools invoke and state messages. Whatever user is passing at this particular time frame, that will be passed here as a data. That is what we are happening going here, like doing there. So first thing, from the line graph itself, we are taking the state graph, and whatever this message state is there, right? This one we already created on the top, right? Same thing we are passing here so that it will understand. After that, we want one node, only one node is to be there. That's why we use this add node function, and we are naming it as a tool calling LLM. Or you can simply say, if you don't want calling, you can use tool call LLM. Okay, tool call LLM, and after that tool call LLM. That's it. and this is nothing but a function. Okay, so tool calling LLM is the top one node you have to mention. You are creating one node, that's why this is the name, and whatever function you have, that one you have to pass. That's it. So you can run this on. Okay, I'll explain this also. First step is start has to be there. After that, it has to attach to that edge, has to connect to the tool calling LLM. Here we are not using any conditional or something, that's why only one edge is there, and after that from this tool calling LLM node to end. Then after that we are doing this, whatever builder is there, right? We are just compiling that, and after that we are displaying things in the screen. So now instead of tool calling LLM, we'll get tool call LLM. I just you can see this. We are done with the graph, and after that we are just checking messages equal to graph dot invoke. We are just invoking the message. I'm just passing it as a hello, just checking how it was going to respond. Hello, how can I assist you? I'm just passing as a message hello, then it was giving it as this. Then again I'm human, right? So I'm passing one more message, multiply 2 and 3. So I'm just checking ideally what the model has to do is a user asks this query, and okay, my answer, I have to call this one. So let's say um, let me run this. After that we'll try one experiment. See, human message is this. After that, I have to call this multiply tool, and arguments are this. So this is what we are trying to do. Let's say I didn't given any data here. Let's say instead of this entire content, I'm just saying like tell me about Paris. I like Paris. Just run this. We'll see how it goes. See, see, look at this. We asked this question, it was clearly giving the message like, I don't have a ability to tell you about Paris. My capabilities are limited to multiplying two numbers. So because we created this tool, it was able to give you like whatever you ask. Apart from this, it can't able to give you any information. Just understand, if it is a normal LLM thing, right, it will return your response, right? But here you can see it's not giving any response. This is the advantage of this tool calling. So you can create some your customized tools functions, and the model will respond completely related to this. There is another way also. This is why it was returning like this, because we created flow like this. You have to, damn sure you have to call this LLM. The function call has to be happen. Tool call has to happen. In case if nothing was there, it was returning some response like this. See, this is the best advantage. And you may ask this question, let's say I'm creating one application, I want a normal response. In case if I don't want to user ask some question, it has to handle both the scenarios. It has to handle the tool, it has to handle the normal scenarios also. That is possible. At the time, what we'll do, we'll create one conditional edge here. Earlier, we created one conditional edge, right? In the same tool call, or if the question is generic based on conditions, we can put some conditional edge. We can say like, okay, you have to reroute to this, then get the response. In that way, also we can deal the scenarios. But here, my point is. Uh, Perfect scenario here, like if you created one flow like this, it will be stick to that flow. Even though you have the LLM capability, it can't give you any response. This is what I'm trying to say here. So I hope you got some clarity in this video. What I covered is I clearly explained you about the tool use, and after that how we can integrate that with the graphs like LangGraph. Those parts we covered, and we'll see the other things in the next tutorials. Hey everyone. So in the last video, we covered how to use the messages, and after that, how to bind the tools, right? So you have some tools, how to bind the tools, and how to get that tool response from, I mean, with the help of LLM, that we covered. Now, what is our plan is, let's say we already did that step, like from the LLM, we're getting, okay, let's say you have a tool, it has to give some response. If you ask any question apart from the tool, it's not giving any response. That is what we observed, right? In this, let me show you this. Uh, Let me show you this. Yeah, you can see this. Apart from tool, I asked some question, it was unable to give it. Now, what we're trying to do is we are proving. we are handling this scenario now. So it in case if it is a question related to the tools, it will give that response. In case if it is the query, user given query is not related to that, it's a generic one. It LLM will handle it. LLM will give the response. That is what we're trying to do now. Okay. So for this, I'm using Gemini API. Okay. I already set the context earlier, so I don't want to use Google. Sorry, OpenAI API because it's a paid one. With the Gemini, we're getting the things in a free way. So that's the reason. So first we need to import the packages, necessary packages. Let me do the things in a live way. Okay, I need these things. Okay, let me copy this, Control A, Control C, go back to this and Control V, Shift Enter. I have to select this Python kernel. Okay, I can see it is running. It will take some time. Let me, meanwhile, okay, I need these things. Okay, see, the plan is simple. So we use the tool calls, and after that, in case if I ask any query which is not related to tools, the LLM has to handle it and it has to give the response. That is what our agenda, our primary goal. Okay, then it is done. I'm not using any OpenAI, so this one won't work. In this place, I have to replace this with the um, Gemini logic. Okay. Mm, So for that, I need to use this logic. Okay, control A, control C. By the way, this is not the best practice. For time being, I'm just giving my API key directly. Okay, but that's not the good way. So you can store that in .env. You can use that. That is one another way of doing the things. Let me, okay, let me control that. Instead of here, I can do below this point. Create a code, and after that, put your logic here. Gemini. This one will work, and after that, I have to copy this, and I have to give Control C. Mhm. Let me give it here normal method. I'm not invoking anything. I have to invoke LLM. LLM is done. This step is done. Method model is done. So we have to replace. We have to copy this, and we have to replace this part. That's it, guys. You have to do some hands-on. Okay, so in this way, you have to do some trial and errors. You'll get to know whether you're making any errors. Means you have to change it. So in that way, you can get some clarity. Okay, now it's executed successfully. So we did this part well. Next thing is same thing. We already know like IPython is just to display that chat. I mean flow chart, LangGraph flow, right? So that one. And from there, this is for creating the start point, end point, and after state graph. We are importing messages state for handling the messages. This is important thing. So this tool node is important, and after the tools condition is important. So now earlier I told you, right, so we need to mention some condition. Based on that, it will understand when it has to call the tool or when it has to call the LLM or when it has to respond as a generic query or when it has to take it as a specific customized tool query. So for that we need these two methods. Okay, so these things are available from the LangGraph pre-built. Okay, so this one we already covered earlier in the previous. In case if you're not understanding this, I created the series. You can you watch the tutorial series so that you will get to know what is each step by step. Okay, so we are just invoking this state message. So we are doing this step. We are adding this and adding it. This is where the interesting thing comes. So I'll explain this. First is like message state, whatever you are getting. So I mean, let me where is this message state? Message state is from the package itself. Okay, so this one, message state, this one we are passing here. Okay, and this is what we are passing here so that we're getting the response also. We're adding one node, mentioning the name as tool calling LLM. Tool calling, we're whatever this method name, right, that we are passing here. So this is the one which is there on the left side. This is the name, and after that, whatever is on the right side That is a method function you have to pass there. So you have to remember in this way whenever we're creating any building any graph. So okay, so first step is like you're naming it as a tool calling LLM, whatever this method, right? So that one you are passing here. After that, you're naming it as a tools, whatever tool node you are getting right from this LangGraph package that you are passing here. You have only one tool, right? So you have this multiply tool that you are passing, and after that there is a from the start there is a edge to from the start there is edge to tool calling LLM. That's why you are creating like this. Then this is the by default step. Whatever happens, it has to connect, and after that, you are putting one condition. What is that condition? Tool calling LLM tools condition. If the latest message from assistant is a tool call, then the the tool multiply has to call, the function has to be called. Otherwise, it has to normal LLM call has to be done. So this is what we mentioned here. You can see this step also. So this tools, you are using this tool node. This is from available from the LangGraph itself, and where we are calling this multiply function. In the earlier we seen right, so we saw the response. We are getting the response like in this way argument a to you have to multiply. This is what LLM given. After that you have to call, right? You have to call the function, otherwise how are you going to get the response? You have to call that function. So the way to call this is in this way. You are clearly mentioning like whenever it identified it's a tool call, you are calling directly. This is what we're doing here, where you are identifying this, you have to call the tools. So currently our tools is only one function multiply. Let's say you have three functions, we will pass all the three, it will decide okay which one it has to call. That we'll see in the next tutorials, but I hope you got the point, right? So in this way we are creating the condition also, conditional edge also we created. We given this tools condition where we are getting this is what default. So then we are creating it, we're compiling, we're displaying. In case if you don't want to name it as tool calling LLM, I'll just mention like tool call LLM, tool call LLM, tool call LLM. Okay, that's it. We'll run this. Now we can see tool call LLM. Now it was changed also. So first it was doing, so okay, this is one thing. After that, we given the content. What is 2 multiplied by 2? It's a 2 multiplied by 7, belong to 7. Okay. So just check. Okay, let me run this. You can see this. You got the result. It identified, okay, this is a tool call. Because we are multiplying, LLM has that context, right? So it identified, okay, I have to do a tool call, 2 and 7 you given, and I have to call this method. It called that method, it given the response. This is what happened now. Let's say now in this, let me comment this. I'll instead of this, I'll use another line. Now what I'll do, uh, hello, give me the plan to go to Paris. Give me a plan to go, give me a plan to explore Paris. Okay. If any one of you from Paris, so invite me. I want to visit. Okay. So, uh, let me run this. See, fantastic, right? So you can see this. Now, earlier we didn't get any response in case if it is out of the question. Apart from tools, it was unable to give anything. Now, you can clearly understand this. See, earlier it was not giving. I don't have any ability to tell about Paris because it's only restricted to tools because we didn't put any conditions there. Now, with the help of this router, we put some conditions, tools conditions. That's the advantage of this conditional just tools condition. This is where the interesting things will come. Now, LLM has the context. Okay, when it has to use the tools, when it has to take the so normal generic LLM call. That's the beauty of this. entire line graph. Now you can see this. You can it clearly given, based on my human message, given the AI response like iconic morning. You have to go to Eiffel Tower and book the tickets, go there, and lunch this, dinner this, go to day two, day three. So it clearly given all the interesting instructions, right? So that's the point I want to cover here. Now, I hope you are enjoying the process. Now you are able to use the tools, and after that, you are able to get the generic response as well. So it was able to, have that clarity when it has to call the tools, when it has to give the generic response. This is what we did now, and I hope you got some clarity. What is the advantage of using this tool node and tools conditions from the LangGraph? Right? So let's say you're building your own customized application. So you can apply in this way. So you created your own tools, you can bind the tools, and after that, you given some context, and after that, whenever you can use these conditions. If it is a generic, LLM will respond. If it is related to tools, your tools get executed and your tools will, the result will appear on the screen. So in this way, you can do a lot of interesting things. This is just the beginning, and we'll see more scenarios in the next tutorials. I hope you learned something new, and so hey everyone. In the last video, we covered about router, right? Like what we did. We call the LLM, and LLM decided like whether it has to be a tool call. Like we did bind tools, right? So it decided like whether you have to go for a tool call, or whether LLM has to give the generic response. In that way, we did simply, right? So we made some conditional edge, and we did that. Let me show you that. This is what we did earlier, right? So tool call directly. Sometimes if it is a generic query, then LLM directly given the response. If it is a tool based one, then it will call the tool, and then tool will return you the response. This is what we did earlier, right? Now what we're trying to do is, we instead of getting the response from the LLM, sorry, in the tool itself, we are passing that back to LLM. So this is nothing but a React. It's one of the agentic framework, agentic architecture, you can say. React means not React or Angular frameworks, right? So RE means reasoning, ACT means action. So that is what reasoning and action. This is known as React. What is every agent will have three characteristics. First is it will take some actions. That is first thing, and after that it will do some observations. Like if you take some action, based on that it will observe something, and after that it will do some reasoning. So based on this action, based on the result, that is nothing but observation, it will observe something. Based on these things, it will do some reasoning, it will perform further actions, right? So it will take some other decisions. So this is nothing but agentic, ideology, or agentic architecture, you can say. Acting like action, observation, reasoning. This is nothing but agentic components. So currently we are majorly dealing with the React framework, React architecture, that is nothing but reasoning and action. So, idea is very simple. So we'll start our approach. We'll do something with LLM bind tools, and after that, we have some tools. We pass those tools to we bind those tools to the LLM. Then LLM will decide based on a user query. It has to return the response, or it has to call the tools. So the twist here is, instead of let's say it will call the tools, instead of directly getting the result to the user, so it will take that output from the tools to like will pass that output to the LLM again. Then LLM will decide how many times it has to call these things, and then at the end LLM will return the results like in a better natural language way. Like directly we ask one query, right? Multiply 2 and 7, and then tool call will happen directly, it return the 14. But now in this case, it won't directly return the 14. So it will return that result to the LLM. Then LLM will decide, okay, user asked this question. Okay, the answer is like the multiplication of 2 and 7 is 14. In that way, model will give you. So see, for example, it seems to be very simple, but if you in order to solve some complex scenarios, right, this is the best way. We'll solve some use case, like we'll solve some problems, then we'll get more clarity. Same here. So here you can see this. And I'm not using chat OpenAI. I'm using this Gemini. Let me copy this. I want to use this logic. This is the first step. Control C. Come back to this agent instead of chat OpenAI. Of course, in this place I need to packages I need to do. Let me uh, go to this. I have to pass the packages. These are the dependencies I need to paste. Go C from here. Control V. First step, run this dependency. Select the kernel. Done right. It was happening. It was executing. You can see this. Take some time. Taking some time. Next step is we are not using any OpenAI. In case if you want to use, you can go ahead with this. I don't think we need to go ahead with OpenAI. We'll try with Gemini. Right. Uh, that is the first step. Then GenAI I'm using. So in this case, we are using three methods: multiply, add, and divide. Earlier we used this only one tool, right? Now we are using this three tools: add, multiply, divide. Here instead of chat.openai, I'm using this Gemini. Okay, this is the changes I want to do. So now, yeah, packages are installed. Go to this instead of we did this part, then AI, we did this. This is the step we have to do. LLM equal to chat, Control C, come back here, come here. These are the methods. LLM, you don't need this part in this place. You have to replace that with this LLM with tools, LLM bind tools, tool, parallel tool calls equal to false. Okay. Okay. Now, okay. So we are currently what we're doing is like we are using multiple tools here. Earlier we used only one tool, like multiply. Now we are using this three tools, and we combine that with LLM. So let me run this. Yeah, it's done. After that, let's create our LLM. And now what we're doing is we are setting some system message. You are a helpful assistant task with performing arithmetic operations. Okay, like addition, subtraction, division. So arithmetic operations. Now in our case, what we are doing is like addition, multiplication, and division. These three things we are performing. Okay, so we set the context and we created one method that is known as assistant. What it has to do from this LangChain core messages, we use this message state. I already covered these things earlier video, so in case if you have any queries, you can go ahead and watch the tutorials. And see what it was doing is like it was messages LLM with tools. Whatever we done right, LLM with tools. This one we're passing, and after that we're invoking system message. Whatever user given input will be there, right? That will be and like currently this one system message plus state message means user given input. Those things will be passed as a message to the model. Okay, for that we are creating this. Let me run this. It was run. Now we have this. Now we are creating this flow. So this is what we want to do, right? We are starting, and after that we have a node that is nothing but assistant. Assistant is nothing but LLM here. Okay, so we have certain tools. Tools. How many tools? We have three tools: addition, multiplication, and division tools. So let's say user ask a query about arithmetic operations. It will go back to the tools instead of giving directly that answer. It will again do multiple iterations. Multiple iterations meaning LLM will decide how many times it has to call the tools, and at the same time, in this example, you can see add 3 and 4, then multiply the output by 2, then divide the output by 5. So in this case, what it has to do, first it has to do addition, then it has to do multiplication, then it has to do the division. So that means three tools it has to call instead of. That's why we are implementing this kind of a loop. What it will do, um, whenever model will understand, okay, addition 3 and 4, first it has to do addition, then it will do addition operation, then that result will be multiplied by 2, then it will do multiplication operation, then again it will do division, then it will pass that result to the LLM, then LLM will return the um, outcome to the user. Okay, this is the process we are trying to do here. So we have this assistant, and after that we normal state graph, these things we already know. From the graph we are taking this state graph, message state, whatever this on the top we have read, that we are passing, we are building that, we are naming it as assistant, and on the method name also assistant, in the top you can see this assistant we are passing here. And after that we already covered last video, so we have to use this tool node so that it will understand these are tools. So that's why we're using this tool node, and we're passing the tools here is like addition, multiplication, division, these tools. Then we are creating the edge. We done the we need two nodes, we done that step. We need this assistant node, then after the tools node, these two things we done. And after that we need to start, and that has to connect to the assistant, start and connected to the assistant. That's why we did this. After that we need a conditional edge, this condition, right? So assistant and tools, assistant and tools, there's nothing but tools condition is like this one, right? So if what it will do, if simple assistant is a tool call, then tools will be executed. If it is not related to tools, generic it will happen. That's why we're putting this tools condition. After that we are connecting that reverting, right? So the from tools to assistant also we are connecting the edge. So in this way we creating the flow. Okay, so let's say if I didn't use this, if I commented this, let's see how the graph looks like. See, same thing, the way earlier we did, same graph. So because now what we have to do, we want to, this tools has to be passed to the LLM only. That's why we are implementing this additional step here, right? Let me run this. Now we can see this tool. You know, see, every time it will change. The graph looks like, I mean, the flow is same. This was this side, right side, left side, those will change. But you understand the concept. That is most important thing. First it will call, and after that, let me run again. Same concept. Now the graph is changed a bit. So yeah. So this is how we done. And after that, we asked a query like, let me run this. Why? What happened? Messages type error. React graph. Where is this React graph? I think we done this stuff. Why we getting this is error? Invoke what message? Is it just, did we change anything? I don't think so. State graph add no tools assistant. The top this one we did, and after that this one. This one is done. After that this one. Okay, got it. Parallel tool calls have to. I think this Gemini doesn't have any parallel tool calls that is available in OpenAI. So this might be the issue here. Okay, let me, uh, okay, let me comment this. First, without this, I'll pass. So this is how we have to solve whenever we face any errors means, because we are not directly trying with the OpenAI API, right? So maybe we'll face some kind of things like this if you're trying with the new things. Okay. Let me save this. Let me run it again. Okay, done. LLM bind rules. It was done. Again, doing this. It was done. Now again, let me do this. Okay, it was done. Let me do this. See, now it was executing. Yeah, no, we won't get in it. This is how we have to solve the errors, guys. Like whenever we face any issues, okay, so we don't need to get scared, and we have to understand, okay, there I got to know, okay. So in this way, if you understand the things from step by step, right, you won't face issues in the debug. So if you simply copy the code and paste it and run it means you don't know where it was getting wrong, how it's getting wrong, okay. So now let me run this again. So now see. We ask a query like add 3 and 2, it will do the addition operation. The tool message is this, addition is done, it was getting 7, and after that what? Multiply that by 2. So 7 and 2 we have to multiply, we got 14, and after that divided that by 5. So it was divided and we got the 2.8 as the final answer. This is the A message. In this way, we implemented the entire agentic flow. Okay, let's do one more interesting thing instead of this message, right? What I'll do, I'll give a generic message. So uh, this December I want to go to Paris, plan something. So I'll do something like this. So we'll do something like this. We'll see how it goes. Let me comment this. Now we'll get a more clarity. Content is I'm going to Paris this December. What are the best places to visit? View the response in 10 50 watts. This would be interesting. Let's run this. Okay, okay. Now we'll see this. Mm-hmm. Okay, see. I can't help you with the travel advice as my current capabilities are limited to performing arithmetic operations like addition, multiplication, division. Same thing, right? So we have to, we clearly uh, done this part. Earlier also we tried, so we have to tell them. So currently, what we did was, so we used multiple tools here. So we have multiple tools, how to access those multiple tools and how to get the response from the LLM. That part we covered. And in the earlier video, we see the results, right? So router. So in the same way, we have to put this kind of stuff, then it will return you the results like this. So it will answer this query as well as it will answer this query. So we need to understand what change we did and what how we implemented all those stuff, right? So this is what we want to do. Uh, yeah. So that's it, guys. So what we did, so instead of getting the results directly from the tool call, so we're redirecting that to LLM, and LLM is giving this. So in that way, we covered the tutorial now. So yeah, and also we covered multiple tools. We implemented one React framework, like reasoning and action framework, and that part we covered now. So in the next tutorial, we'll see agent with memory, and after that, we'll see how the things works, and after that, we'll see some practical examples and practical implementations. Okay, let me run it again. Let me show that results. Yeah, that's it, and take care. I'll see you in the next tutorial.